Hello guys, I hope you are fine. Me too, I'm fine. So we thank God for yet another opportunity that we can learn together. And guys, it's always good to give thanks to God, for He is good. And so guys, let's now start solving our questions. We go to Roman 1, or I read the question first. And the question says, evaluate the integrals. And these are definite integrals because they have limits, that is lower limit and upper limit. So let's start with Roman 1. So guys, for this one, we are going to divide it into fractions so that we put every term here, we put it under this denominator. So that guys, we shall have something like this: integral from 0 to 1. Then I can put x raised to negative 3 all over x raised to negative 4, like that. Then plus 2x raised to negative 2 all over x raised to negative 4 plus x raised to negative 1 all over x raised to negative 4. And the integral is there. That is dx is there. So guys, from there we go now to the next step. Still integral from 0 to 1. We can divide that. That will give us x raised to negative 3 now plus 4. Using the law of indices, guys, when x goes up, it shall be x raised to 4 plus 2x raised to negative 2 now plus 4 plus x raised to negative 1 again plus 4 dx. From there guys, we come and now that is we actually now be able to find the indices for that. So that one will be from 0 now to 1, that integral. This one now becomes, by the laws of indices, it shall be x raised to negative 3 plus 4 is actually 1. So it's x raised to 1. So you can even leave it like that. Plus 2 x raised to negative 2 plus 4 is actually 2 x raised to 2 plus x raised to negative 1 plus 4, that is actually 3 dx. So guys, now we come and integrate. So when we integrate guys, we shall have integrating x, it will be x squared all over 2 plus 12 divided by 4 is 3, like that. So finally guys, our solution is going to be 14 plus 3, that is 17 all over 12. So guys, that is our solution for that question. So guys, let's go to the next question. This is the answer. So guys, here is our next question, and then we want now to do it guys. So what we do guys is that we come and integrate direct, as we have the figures are integratable without having to manipulate them. So I will put my bracket there. Come integrate 3 cos x. This is going to be 3 sine x. So when guys you are doing that, try also to differentiate and see whether you get your original values. If you get your original values, then you are correct. And that's why I can say the differentiation of sine x is actually cos x. The constant remains the same. Then we go to the next. 2 integrate sine x is actually cos x, but now it will have a negative here, guys. Because when you differentiate cos x, you get minus sine x. And because this one does not have a minus, then our solution then is going to be, we had to add a minus, not counting this minus. Assuming that sine is alone, then this one will have a minus like that. So now guys, we are going to find that this is now going to turn to plus. Then plus, differentiate, integrate 1, then you get x like that. So guys, this is what we get. 3 sine x plus 2 cos x plus x. Now we can put our limits, guys. Our limits is from 0 to pi over 2. So let's begin by putting pi over 2. If you put pi over 2, you shall have 3 sine pi over 2, and of course pi over 2, guys, is 90. Pi over 2 plus 2 cos pi over 2 plus now pi over 2, like that, minus. Now we put the lower limits. For the lower limits, we have 0. So the first term will be 0. The second term, this is 0. The second term is going to be 2. Because cos 90 is actually supposed to be 1. Then 0 here. Then it means we shall have something like that. Actually, it's going to be 2 there. So this one we shall have, this will be equals to 3 sine of 90. The sine of 90 is actually 1. So we shall have 3 plus, we go now to cos 90. For cos 90, that gives us 0. So this one will not be there, guys, because that one is going to be 0. This one is going to be 1. So we shall have now pi over 2 there, and then minus 2, like that. So finally, guys, we are going to have 3 minus 2 is actually 1. Then it will be 1 plus pi all over 2. So guys, this is our solution, even as you can observe right there. That is pi over 2 is our solution. And guys, if we check there above, you find these are our answers. So guys, thank you for listening to me. Bye bye.